You're a high school chemistry teacher, and you are ready to teach your students all about periodic trends. But you're wondering how best to keep your students engaged through all these different vocabulary terms. You also want to make sure that you follow the next-gen science standards when it comes to matter. In particular, HSPS 1-1, valence electrons and properties of elements. And the NGSS also states observable features of the student performance. Zoomed in are the elements in the periodic table, their valence electrons, patterns associated with their location and number. This NGSS standard also dictates that we have to emphasize the trend in reactivity and electronegativity, as well as the relative sizes of atoms. How are we going to do this while keeping our students interested? This video is for you if you wish to hear how best to engage your students when teaching periodic table trends. Here's how. You're seeing here the handout that I've constructed, titled Periodic Table Trends. The purpose is clearly specified that through modeling and data gathering and note-taking/note making, the students will learn what they need to know. Check out the link above for a previous video that I've made about this lab handout, but I'm now going to share with you an updated version. The first thing you want to do with your students is to model the atoms. Which one should we pick? I would recommend choosing the following 4 atoms: alkali metal, lithium, alkali metal, rubidium, halogen fluorine, and halogen iodine. Now, in the past few years, my students have modeled these 4 elements digitally. But our school recently underwent a renovation, and so I was ready to use the whiteboards located inside these cubbies as a platform to model these 4 atoms with my students. You're seeing here the first example, lithium, and below that rubidium, both group 1 metals. And on the right, we see the atom fluorine, as well as iodine, modeled by another student. Since lithium and fluorine are in the same period too, it correctly shows that the nucleus is increasing in terms of size. Awesome! However, this student did not correctly model the decrease in size of the atom. Larger nucleus, higher Zeph value, the same number of shells should be pulled in more tightly. Let's zoom in on period 5. We're seeing here rubidium and iodine. This student correctly showed a decrease in size of the atom, but unfortunately, it's not showing a correct increase in size of the nucleus for iodine compared to rubidium. Clearly, modeling these 4 atoms correctly is a challenge. I'm showing you here my key, my digital key of these very 4 atoms. Again, the video link above shows you how to do this in a digital way. And the insert drawing tool would enable your students to create scaled drawings of these 4 atoms based on the atomic radius. Next, I would recommend having your students collect some data. I've been using the CODAP website, and again, my previous video shows you exactly how to extract that data from this site. Here you're seeing a screenshot showing you the atomic radius as a function of atomic number. Clearly, as the atomic number increases, the size of the atom decreases. Except there's an anomaly here. Could that be the inert noble gas neon? This particular graph shows you the atomic radius as you travel down group 1. The alkali metals clearly show an increase in their size as a result of the added shells as you travel down the group. You can have your students collect additional data, including ionization energy, electron affinity, possibly even melting temperature. Once you've done that, they're ready for the 3rd step. The 3rd step is to have your students practice with the periodic trends vocabulary. I'm showing you here 6 different words, but you might wish to change it up a little bit to fit the needs of your students. You're thinking vocabulary words can be kind of dull. How can we make it more playful? One idea is to pair up your students, give each of them the list of words, but not the definitions. They are covered up, and give them each a die. They roll the die, and depending on what face the die lands on, that's the word they will have to explain verbally to their partner. This way you make the practice of vocabulary more like a game. Now, this idea, using dice when practicing vocabulary words, did not come from me. I first heard about it from Brennan Koch from Stoich Decks. Check out one of his blog posts, The 5 Strategies to Help Kids Talk More About Chemistry. And he describes the dice method in this blog post. So to recap these first 3 steps, you first have your students model the 4 atoms in the periodic table. Next, you have them collect periodic trend data so that they can see the bigger picture. Third, you have them playfully practice with 6 key periodic table trend vocabulary words. And then they're ready for some note making. That means they are basically going to extract everything they've learned so far and put it in their own words. You can start with the following diagram. It's similar to the picture that I started this video with, but notice there are 2 arrowheads for each of the terms. But to make sure that they understand the big picture, students first have to figure out which arrowhead points to the correct trend. And when it comes to that note making, here is my sample Google Keep note of the periodic table trends. Check the video link above that takes you to my Google Keep video in which I explain exactly how to take notes with your high school science students in Google Keep. You want to take that note making to the next level? Have your students do a CER, a claim evidence reasoning statement. Shown here again is that same snip, that same image of the data for the atomic radius. They make a claim, they look at the evidence, and then they have to explain why the trend follows that particular way. This concludes the 4 steps that I take with my students to get them to understand periodic table trends. I have not shown you here the summative assessment so that I can eventually evaluate whether they actually grasp the whole material. If you like this resource and are interested in any of the other resources that I make available, then go to the link in the description below. It'll take you to my landing page, and in exchange for your email, you will have access to the following Google Doc with all my science handouts and associated videos. Thank you very much for watching. Bedankt voor het kijken. Tot ziens, and see you in the next video.